Practice C has to do with equilibrium. So we're still using Coulomb's law, and what we're going to do today is equilibrium means that the net electric force on a charge has to be equal to 0. So that when we sum up or add all the forces, it has to be equal to 0. And that's it. All right, so let's look at number 1. So we're going to do C1. It says a charge. So what we're going to do is we're going to first write our given. A charge of positive 2 times 10 to the negative 9 coulombs. So I'm going to call that Q1. Is placed at the origin. So now they're making reference to a graph. So that means I need to draw a picture. You cannot do this without drawing a picture. So here's my picture, X and Y, because when they say in the origin, they're referring to a graph. So here, I'm going to draw my Q1. And another charge is placed at X is equal to 1.5 meters. So I'm going to call that one Q2. And Q2 is equal to 4 times 10 to the negative 9 coulombs. And I'm going to put that charge over here, Q2. And I know that this distance here is 1.5 meters. Find the point between these two charges where a charge of 3 times 10 to the negative 9 coulombs should be placed so that the net force on it is 0. So now I have a third charge, Q3, which is 3 times 10 to the negative 9 coulombs. And I am not sure where this charge is going to be. So I'm just going to randomly just put it anywhere in my diagram. Okay? Now what they want you to do is they want you to find equilibrium, and that means that the net electric force on the charge is 0. Okay? So what does that mean? Well, first of all, I'm not sure where this charge is going to be, so I have to call it something. So I know that this distance is 1.5 meters. So what I'm going to do is, has this been blurry the whole time? What I'm going to do is, I'm going to just call this distance here P for point. You know, like this is some point from the origin. And then this distance here is 1.5 minus P. And that's it. Now, what does equilibrium mean? So because the resultant force on Q3 is 0, F31 and F32 must be equal. That would give us equilibrium. So what that means is that here's Q1. So Q31 and Q32 have to be equal. So what does that mean in math terms? In math terms, that means that F31 has to be equal to F32. So that means that this force is going to be equal to that force. And then it will be in equilibrium. Okay? So what is F31? Well, F31, again, Coulomb's law is K, Q3, Q1 over R31 squared is equal to K, Q3, Q2 over R32 squared. Now, when I look at that, I can say, so all I did was this F is the electrostatic force. So now I can start getting rid of stuff. I see that K is on both sides, so I can cancel that. I also see in the numerator they both have Q3, so I can cancel that. And I'm just trying to do this mathematically. Now, I could leave those in because I have those values, but this will make my math a lot easier. Okay? So now when I rearrange, I have Q1 over R31 squared is equal to Q2 over R32 squared. But now I don't know what these distances are. I know this one distance is 1.5, but I don't know these. So now what I'm going to do is, I know that according to my diagram, this is the distance between Q1 and Q3, which is R31, which is actually P. And then the distance between Q2 and Q3, which is R32, is actually 1.5 minus P. So remember, R31 is P, and R32 is 1.5 minus P. So now I'm going to take this information and substitute in, and we'll see that we only have one unknown, and our unknown will be P. Now, a lot of you just want to plug values in. You can do this mathematically any way you want to. I have Q1, and instead of R31, I'm going to put P. So P squared is equal to Q2 over 1.5 minus P squared. Now, what happens is I'm going to have to multiply this out. And you notice on here I'm also going to have a P squared. So when I multiply it out, I would cross multiply. I would have P squared Q2 is equal to 1.5 meters minus P squared Q1. I just cross multiply. Then I'm going to try and simplify. So what I did was, and this is where we're all a little different as far as our algebra. So what I did was I just took the square root of everything. Okay? So when I took the square root, I ended up with P radical Q2 is equal to 1.5 meters minus P radical Q1. So I have P radical Q2 plus P radical Q1 is equal to 1.5 meters radical Q1. This is step-by-step algebra. So P radical Q1 plus radical Q2 is equal to 1.5 meters radical Q1. You know me, I like to rearrange the equation to substitute for the unknown in terms of the known and substitute and solve. So, the way you do your algebra is up to you. So now I have P is equal to 1.5 meters radical Q1 over radical Q1 plus radical Q2. So now I have my unknown in terms of the known, because that's the way I always like to do it, because I know for me, if I do that, I'm not going to make a mistake. Now I'm going to substitute in my values. So the hardest part about this problem is the algebra. Now the other homework problems aren't like that. So now I substitute in my values for Q1 and Q2. And then I put it on my calculator. And then I get my final answer, which is 0.062. And that's it. So really, the new physics for this is that equilibrium means equal. So in order to put that charge in the middle, this force has to be equal to that force. I substitute in Coulomb's law. And then in this one, I was just finding what that point was. Where did that charge have to be placed? And that's it.